Have you ever imagined crossing the Atlantic in under 4 hours without sacrificing comfort? For decades, that dream felt like science fiction. Or, for those who remember the Concorde, it felt like a retired relic of a louder, faster, but far less comfortable era. Supersonic travel once touched the skies, but never quite captured the hearts of everyday passengers. Too cramped, too loud, too expensive. And in 2003, Concorde took its final flight, leaving behind both nostalgia and unanswered questions. But now, that dream is being reimagined. Meet Boom Overture, the next-generation supersonic airliner. Sleek, futuristic, and ambitious. Its mission? Not just to fly faster than sound, but to make passengers feel like they're stepping into the future. Not in a military jet, not in a metal tube, but in a cabin designed for human comfort. The kind that feels more like a private lounge than an airplane. But here's the question we're exploring in this video. Is Boom Overture truly delivering supersonic comfort, or is it just really smart marketing hype? And more importantly, can the laws of physics and engineering actually allow for a luxury experience at Mach 1? Stay with us until the end, because we're going to unpack not only what Boom promises, but what it may be hiding. By the end, you'll understand whether this aircraft is about to change the aviation industry, or simply stir our imaginations without taking us very far. Now let's dive into the roots of this obsession. The supersonic temptation. Since the Wright brothers first lifted off the ground, humans have been obsessed with going faster. Speed is hardwired into our psychology as a marker of progress. It's why we marvel at jet engines, racing cars, and high-speed trains. Speed gives us the illusion of control over time itself. It shrinks the world. It puts cities, economies, and people closer together. But in aviation, speed has always come at a cost. The Concorde, which first flew in 1969, was a masterpiece of engineering, but a nightmare in terms of comfort. Seats were tight, noise was constant, and the interior felt more like a business shuttle than a luxurious aircraft. Yet despite its flaws, people still romanticize the Concorde. Why? Because humans also value exclusivity, and very few ever got to fly faster than sound. The Concorde wasn't just a plane, it was a status symbol, a club, an experience reserved for the powerful and the privileged. Boom knows this, and Boom is tapping into it. Their language isn't just about speed, it's about experience. Cabin renders show spacious seats, wide windows, soft lighting.
The website speaks of serenity, sustainability, and silence.
These are words designed not for engineers, but for dreamers. For business travelers, aviation fans, and frequent flyers who want more than just efficiency. They want to feel something. They want to feel special. Psychologically, that's smart. Because modern air travel has become routine. Crowded terminals, middle seats, narrow aisles, long lines. In this environment, Boom isn't just selling faster travel. It's selling escape from the ordinary. And this is where it gets interesting. Boom Overture isn't just trying to improve aviation specs. It's trying to emotionally reconnect us with flying. Remember when flying felt like an event? When passengers dressed up for flights? When a boarding pass was more than just a QR code? That sense of wonder has been lost. Boom wants to bring it back with a supersonic twist. But here's where things get tricky, because comfort and speed often pull in opposite directions. High-speed flight introduces engineering challenges, heat buildup, cabin pressure, airframe stress, and fuel consumption. All of that impacts what designers can actually offer inside the aircraft. When you move faster than sound, everything from the window shape to the seat layout needs to serve not just the passenger, but the physics. So again, the central tension returns. Can Boom really deliver both speed and comfort? Or are we falling in love with a story that hasn't yet flown? This is more than just an aviation question, it's a human question. Our brains are built to respond to novelty, to promises of the future. When a brand tells us that something is next generation, it triggers the reward centers in our brain. Psychologists call this anticipatory dopamine. We feel good not because something has happened, but because we believe it will. Boom is riding that wave. And if you've seen the images, you know why. It looks beautiful. It sounds futuristic. It feels like a dream that's finally coming true. But as any seasoned pilot will tell you, it's not the takeoff that matters, it's the landing. In the next section, we'll go deeper into Boom's promises. We'll explore the cabin features they claim will redefine supersonic travel. From seat design to noise control to how they plan to keep passengers comfortable at 60,000 feet. And by the end of this video, you'll know, is Boom Overture really building the future of flight? Or are we just hearing the sound of well-polished hype? Stay tuned. You won't want to miss what comes next. Boom Supersonic isn't just promising speed, it's promising a new kind of passenger experience. one that combines innovation, luxury, and environmental awareness, all inside the cabin. If the Concorde was built for engineers, the Boom Overture is being built for passengers. That's the message they're sending. At the heart of this promise is the idea that comfort doesn't need to be sacrificed for speed. Boom claims that every element of the Overture's interior has been designed with human well-being in mind. From the seating layout to the lighting to the noise level, everything is being shaped to offer what they call a serene, tailored experience. The first major claim is space. Boom says the Overture will carry between 65 and 80 passengers in a single-class layout. That's far fewer than a standard commercial airliner, but for good reason. By limiting the passenger count, Boom says it can offer more personal space per person. Every seat is by a window. There are no middle seats, there's no economy class, everyone gets a direct aisle access. This is meant to signal equality and exclusivity, two powerful emotional triggers. In today's flying world, space is a luxury. Boom is betting that people will pay more for a seat that feels private, even if the flight is shorter. According to research in environmental psychology, personal space directly affects perceived comfort. When humans feel boxed in, their stress levels rise. But when space is open and personal, anxiety drops. Boom seems to understand this deeply, and they're applying it to every seat on the plane. Then comes seat design. While full technical specs haven't been made public, Boom has hinted at ergonomic seating inspired by business-class layouts. The goal isn't just physical comfort, but mental ease. That means wider seats, adjustable headrests, and clean lines that mimic modern interiors. Studies show that aesthetics influence psychological comfort. When a space looks well-designed, passengers report higher satisfaction, even if nothing else changes. That's the illusion of comfort, one of the most powerful tools in aviation design. Boom also emphasizes the importance of acoustic control. One of the major flaws of Concorde was the overwhelming cabin noise, especially from the engines. Boom says it's taking a different approach. Through refined aerodynamics and next-gen materials, it promises a quieter cabin, even at supersonic speeds. Quiet doesn't just mean silence, it means clarity. Less noise allows passengers to relax, sleep, and hold conversations without strain. Psychologically, silence is associated with luxury. In high-end hotels, in spas, in luxury cars, quiet is a premium feature. Boom wants to bring that experience into the sky. Lighting is another major component. Boom says its cabin will feature dynamic lighting systems designed to reduce fatigue and jet lag. This is based on circadian science. Exposure to light at certain wavelengths can either stimulate or calm the brain. Airlines like Qatar and Singapore have already used this research to improve long-haul flights. Boom is applying it to shorter, faster journeys, but with the same goal, keep passengers feeling balanced, alert, and refreshed. Then there's the windows. Every seat gets one. But these aren't just standard portholes. Boom is designing larger, deeper windows that offer more natural light and broader views. The psychological effect of window access is huge. Passengers who sit by windows consistently report lower levels of anxiety and a stronger feeling of control. When the Earth moves below at Mach speeds, that view becomes not just beautiful, but grounding. Beyond the physical features, Boom is pushing an emotional narrative. Words like serenity, focus, connection, and presence are used throughout its marketing. These words aren't accidental, they're rooted in psychological appeal. Boom isn't just selling a faster way to get from New York to London. It's selling the idea that time on board can be reclaimed, that instead of being drained, passengers can be restored, that instead of just arriving faster, they can arrive better. Another layer of Boom's comfort pitch is sustainability. While it doesn't directly affect cabin feel, it affects the emotional environment of the flight. Boom says the Overture will run on 100% sustainable aviation fuel. It's part of their attempt to build not just a faster plane, but a more responsible one. Passengers who care about climate impact may feel more at ease knowing their flight aligns with future-forward values. It turns environmental consciousness into a subtle form of psychological comfort. The company is also working closely with suppliers like Collins Aerospace to refine everything from seat materials to climate control systems. These are the details that make or break comfort. Temperature regulation, air quality, scent neutrality. These factors don't make headlines, but they deeply affect how we feel in a cabin. Even a 2-hour flight can feel exhausting if the air is too dry or the seat fabric traps heat. Boom appears to be addressing these concerns by designing systems around human physiology, not just engineering specs. Put together, the message is clear. Boom is designing the Overture not just as a fast plane, but as a wellness-focused experience at high altitude. It's a complete rebrand of supersonic travel, from noise and speed to peace and presence. But no matter how beautiful the renders or persuasive the words, there's a deeper question still hanging in the air. How realistic are these promises when challenged by the hard science of supersonic flight? Because as any aviation lover knows, dreams don't fly unless the physics allows it. And that's where the next chapter begins.
Promises are exciting.
But aviation doesn't run on promises. It runs on physics, fuel, and engineering limits. And when it comes to supersonic flight, the reality is far more complex than any glossy brochure or digital render can show. Let's begin with speed. The Boom Overture is designed to cruise at Mach 1.7, roughly 1,300 miles per hour. That's more than twice the speed of most commercial airliners. At that velocity, a typical transatlantic flight could be cut nearly in half. It sounds thrilling. But achieving and sustaining that speed introduces a series of aerodynamic and structural challenges that directly affect what happens inside the cabin. One of the biggest issues is heat. At supersonic speeds, friction between the aircraft's surface and the air produces extreme temperatures. The nose and leading edges can reach over 300 degrees Fahrenheit. This heat doesn't just stay on the skin. It affects the cabin environment, the materials used, and the systems responsible for passenger comfort. Designing an interior that remains cool, quiet, and stable while the exterior faces such intense forces is no small feat. The Concorde faced this exact issue. Its cabin, while pressurized and climate-controlled, was often described as tight, warm, and acoustically harsh. Engineers had to work within physical limits that didn't allow for generous space or insulation. The result was a cabin experience that prioritized function over comfort. Boom claims it can do better, but every inch of comfort inside the Overture must be earned against the forces outside. When an aircraft travels at supersonic speeds, every design choice becomes a compromise. Larger windows, for example, increase structural complexity. Wider cabins add drag. Thicker insulation adds weight. Every additional kilogram has consequences for fuel efficiency and range. Passengers want more room, but engineers want less weight. Passengers want bigger windows, but designers need smaller openings to withstand pressurization and stress. These tensions define the very core of aviation design, and they don't disappear at Mach 1.7. They get worse. Then there's the matter of noise, not just outside the cabin, but inside it. Supersonic aircraft generate what's known as shockwave noise, and even with advanced materials and insulation, vibration and hum can seep into the interior. The Concorde was notoriously loud, both inside and out. Boom has promised a quieter experience, using modern composites and design tweaks to dampen sound. But there is no escaping the fact supersonic flight is loud by nature. Cabin noise has a direct impact on human psychology. Prolonged exposure to even moderate noise levels increases stress, fatigue, and reduces the perception of comfort. If Boom cannot significantly reduce interior noise compared to the Concorde, passengers may find the experience far less luxurious than expected. Temperature is another key variable. Supersonic jets must operate at higher altitudes, up to 60,000 feet, to minimize drag and maximize speed. But at those altitudes, cabin pressurization becomes more delicate. The air outside is thin and freezing, and the pressure differential puts stress on the fuselage. To maintain a comfortable cabin environment, the aircraft's systems must balance oxygen levels, humidity, and temperature far more carefully than on a subsonic flight. Any imbalance can lead to dryness, headaches, or even mild hypoxia. It's worth noting that the Concorde's cabin was pressurized to only about 6,000 to 8,000 feet, which was bearable, but not ideal. Boom will have to do better, especially if it's offering a wellness-forward experience. Cost is the other reality check. Supersonic flight consumes far more fuel per passenger mile than subsonic travel. Even with sustainable aviation fuel, the economics are tough. Tickets will likely be priced at a premium, possibly in the range of business or first-class fares. This raises another question. Will passengers expect private jet luxury for that price? And if they do, can Boom deliver it? Adding premium comfort features like lie-flat seats, gourmet dining, or ultra-quiet zones may not be possible without further reducing capacity. And reducing passenger capacity drives prices even higher. It's a feedback loop that airlines know too well. History supports this caution. The Concorde operated for nearly 3 decades but never turned a consistent profit. Its flights were iconic but limited. Its maintenance costs were enormous. And after just one fatal crash and rising operational expenses, the program was retired. Psychologically, there's also a tendency to idealize the past and project expectations onto the future. The Concorde became a legend precisely because it was rare. Most people never flew it, but they imagine it was glorious. Boom is walking into that emotional halo, but also that trap, because expectation is now higher than ever. Passengers don't just want speed, They want a meaningful experience. They want quiet, light, privacy, space, and safety, all while flying faster than sound. But the laws of thermodynamics, material science, and fluid mechanics don't adjust to desire. They're constant. And while technologies have advanced since the Concorde's time, the essential challenges of supersonic passenger flight remain deeply real. There is also the regulatory environment. Supersonic overland flight is still banned in many countries due to sonic booms, which limits potential routes and adds complexity to scheduling and profitability. The FAA and other global aviation authorities will need to certify not only the aircraft, but also the experience, inside and out. So, while Boom's vision is compelling, the road to delivering true supersonic comfort is narrow. It will require not just engineering brilliance, but unprecedented cooperation between designers, regulators, and airlines. For now, Boom is a promise on paper, and aviation lovers, perhaps more than anyone, understand the gap between a concept aircraft and one that's truly ready for takeoff. The renderings are beautiful, the words are inspiring, but the only proof that matters is how it feels at 60,000 feet, at Mach 1.7, with a cabin full of people expecting nothing short of magic. Speed alone has never been enough to win the skies. If it were, the Concorde would still be flying today. But passengers want more than velocity. They want value, safety, comfort, and emotional satisfaction. And that's where Boom Supersonic stands today, not just at the edge of a technological breakthrough, but at the crossroads of perception and reality. The Boom Overture is not just an aircraft under development, it's an idea that's already taken flight in people's minds. It carries the emotional weight of the Concorde's legacy, the hope for a faster future, and the promise of a better flying experience. That combination is powerful, but it's also fragile, because the higher the expectations, the smaller the margin for error. So where do we stand now? Boom's vision has stirred global attention. Its cabin designs suggest elegance. Its promotional language speaks of serenity and innovation. Its ambitions stretch beyond transportation, toward reimagining how people experience time in the air. And from a psychological standpoint, that is exactly what makes it so appealing. Human beings are wired to crave time control. We chase anything that gives us the feeling of gaining time. Fast food, high-speed internet, express lanes, overnight shipping. Supersonic travel is the ultimate version of that fantasy. The idea that we could leave New York and be in London before lunch isn't just exciting, it's emotional. It touches our fear of time slipping away. It makes us feel powerful. But emotional appeal must eventually meet physical experience. It's one thing to show clean cabins and soft lighting in digital renderings. It's another to maintain that environment at 60,000 feet, moving at nearly twice the speed of sound, across oceans, with real passengers, real costs, and real consequences. Comfort is not created by visuals alone. It's the result of hundreds of details working in harmony. The way the seat supports the spine, the silence of the air ducts, the softness of cabin lighting during descent, the stability of temperature and pressure, the air quality, humidity, legroom, service rhythm. These are invisible luxuries, felt, not seen. Boom must get them right, not once, but every time. And then there's the economics. Supersonic travel demands higher fares, which limits its accessibility. If it becomes a product only for the elite, it may win headlines but lose mass adoption.
That's the same mistake Concorde made.
A marvel of engineering, yes, but disconnected from commercial viability. For Boom to succeed long-term, it must balance exclusivity with consistency. It must offer something special, without becoming something niche. That balance is difficult, especially in an aviation market dominated by cost efficiency and low-margin operations. There's also the question of public tolerance. Sonic booms are still largely banned over land. Environmental concerns continue to grow. Even if Boom uses 100% sustainable aviation fuel, scrutiny will remain high. Public perception matters. An aircraft cannot fly fast enough to outrun public opinion. Yet despite all these challenges, there's something undeniably bold about what Boom is trying to do. It's not just building a plane. It's trying to change the rhythm of modern life, to bring cities closer, to restore the wonder of flying, to make the sky exciting again. And maybe that's why so many aviation lovers are rooting for it. Not because the obstacles aren't real, but because the dream still is. Throughout history, every leap in aviation has started with impossible expectations. The first jets were doubted. The first wide bodies were feared. Even the idea of international commercial flight was once ridiculed. And yet, time and again, progress pushed through. The difference now is that comfort is no longer optional. In today's world, where travelers are more informed, more vocal, and more selective, an aircraft can't rely on speed alone. It must feel like the future, not just fly like it. Boom's greatest challenge may not be engineering or regulation. It may be delivering on the emotional contract it has created with the public. A contract that says, you won't just go faster, you'll go better. If it can do that, if the final aircraft matches the promise, then Boom could redefine what we expect from air travel. Not just for the elite, but as a stepping stone toward a faster, more human-centered aviation era. But if it falls short, if the comfort is compromised, if the pricing alienates, or if the noise and fuel burn return to Concorde-era levels, it risks becoming just another beautiful idea that never truly took off. For now, the world watches. The aviation community listens closely. Enthusiasts compare, engineers debate, and travelers imagine. The Boom Overture has not yet flown, but it has already traveled far in our conversations, our expectations, and our hopes. And maybe, just maybe, that's the real beginning of something extraordinary.